Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Husna Amira binti Muhammad Anwar. My matric number is CF218. I am from Group 2. I will introduce about our project. So the project title is Trust Bridge. And then, firstly speaking, that bridge is a structure that spans a physical barrier such as a body of water, a valley, a road, or a rail line without obstructing the path beneath it, meaning that bridge is a structure that can move a person or a car from side to another side. And as we all know, there are three types of structure determination, which is statically indeterminate, statically determinate, and unstable structure. Uh, Most of our bridge are statically determinate, and we for our project we use LimPro as a software to design a bridge. This is because LimPro is a software that is simple to analyze and to for plane and frames design. So for our project, we built a bridge with 29,700 length and the height is 3,430. We uh, com- we compare the LimPro software result with the manual calculation for our project. That's all from us. Thank you.
Hi, Assalamualaikum and good day. I'm Fatina Petra Mali and I will continue with manual calculation. First of all, this is our design of bridge and this design is from Peter Creek Bridge. And this is our layout for bridge and the bridge is made of concrete for deck. For UDL here is represent self-weight which is to 25 kN per meter and it is based on JKR standard. While for 2-point load here, it is represent for vehicle load which is 8,000 pound and 30,000 pounds and it is based on H2H20 and the area for this bridge is 400 millimeter square. Next, by using this equation, we got that this bridge is statically determinate. Before we do further calculation, we have to make sure that all the unit is same so that the calculation will be easy. So first of all, for UDL load, we have to change into point load and to change it, we have to multiply the UDL which is 25 kN per meter with the overall length of the bridge which is 27.9 meter and then we get the new point load is 697.6 kN. For vehicle load, it is in pounds, so we have to convert it into kilonewton. 1 pound is equal to 0.0044 kilonewton. So for 8,000 pound, it is 35.6 kilonewton, while for 32,000 pounds, it is 142.34 kilonewton. Next, you are going to do first step of the calculation, which is finding reaction support. By using this equation, summation of mg equal to 0, we get the value of Ra equal to 419.93 kilonewton, and by using summation of Fy equal to 0, we get that the value of Rg equal to 455.51 kilonewton. Then we move to step 2, which is calculate real force by using method of joint. There are two steps of method of joint, which is firstly we have to isolate each joint of the truss. Then step 2 is calculate reaction force. So this is the example of calculation and we have to apply the same step for every joint. Okay, this is the result that we get. The negative value is represent for compression while positive value is for tension. Next, step 3 is we have to calculate vertical force, and for this vertical force, we apply the same method and step as real load. And note that the deflection is occur at point D. After applying the same method and same step as real load, this is the result that we get. Same as wave load, negative value represent compression and positive value is for tension. Move to step 4, which is we have to draw a table. There is 4 columns, which is for member, length, F, mu and F mu L. Then the total that we get is 88,844.711. Then for the final step is we have to find vertical displacement at point D by using this equation. Then we get the vertical displacement at point D is 1.1106 times 10 to the power of negative 6. Hence, the direction of the deflection is same as unit load, which is downwards. So that's all from me. For the next slide, I will pass to Haris. Thank you.
Thank you, Jiha. Assalamualaikum. My name is Haris Muklis bin Rosli, and I will cover the software calculation part. For this calculation, we use LinPro software because it is the easiest and the simple software to use. Next, we go to input of load. As you can see, this is our trusses. We design it just like the manual calculation where we have 21 members, 3 reaction because this is pin and this is roller, and 12 joint. And of course, the span of each member is also the same as manual calculation. And for the load, we use the same as manual calculation also, which is 697.5 kN at joint J, 35.6 kN at joint C, and last one is 142.34 at joint E. After putting all the loads at their place, then we can analyze the trusses. So we get the reaction at the bolt support. We have pretty much the same answer like manual calculation, which is RA equal to 419.93 kN and for RG is 455.51 kN. After that, we can get the internal for real forces. So this is the result. Most of the part is the same as manual calculation, but there is some part that's slightly different from the manual calculation. And next, this is the internal force for virtual load. It is pretty much the same with the manual calculation, but just different decimal places. And last but not least, this is the deflection that we get from the software. As you can see, the highest deflection is at joint 3, which is 5.4 times 10 to the power of negative 5. It is slightly different from the manual calculation. That's all from me. Thank you.
Assalamualaikum. I'm Fatin Shamira. We'll continue with discussion. From our project, the selected bridge is taken from the Peter Creek Bridge design. The truss bridge has been designed by using AutoCAD software. The calculation have been completed using 2 methods, which are by manually calculation and LinPro software. The dead load for this bridge is based on JKR standard, which is 25 kN per meter, while for live load is based on AASHTO. The value of young modulus we assume 200 gigapascal and area we assume 400 mm². At the end of the calculation, there is a small difference between manual and the software. The difference mainly on the value part due to the rounding off. We prefer to use software instead of manual procedure. This is because software is playing a virtual role in giving the value with good accuracy when compared to calculating the value manually.
Hello and Assalamualaikum. My name is Haji Hafiz. And as for conclusion, all of the group members are able to gain experiences in building, calculating and design the truss bridge. Next, all of the group members also can practice the theoretical and the calculation that learned during classes into the bridge. For calculation, we use the joint method for manual, and we use the LinPro software to calculate the deflection of trusses, and we compare it with the manual calculation. Thank you.